Hi all, and welcome to another Generative Components tutorial. Today will be the beginning of a new series on how to automate the generation of ramps, from basic concepts right through to complex free-form ramps that meet code requirements. In this first part, let's look at quick concept ramps generated using the lawcurve node and some 2D arcs. So let's get started. For this exercise, I'm just using two simple 2D arcs that will indicate the inside and outside position of the ramp in plan. I've created the arcs using the Open Buildings arc tool, however this can be generated using any application. Hovering over the lines, you can see they are just arcs. I like to start by clicking on the point tool to generate the base CS by clicking yes and OK. And to utilize the arcs, I could use a range box, however in this tutorial I would like to show you an alternative method. For this, I will drag in an arc node and change its method to by element. I can then copy and paste the node so we have a separate node for the inner and outer arcs. So for this I'll rename the nodes inside arc and outside arc. Then by clicking on the element path box, we can then click on the arc in the window and the element ID is automatically placed in the element path. And we can use the same method on the outside arc. Next, I'll drag in the lawcurve and change some of its default settings. I'll change the number of control points to 3, the Y max to 1000, this will be our height for our ramp, and I'll change the grid spacing to 100. Now if we click on the graph, we can drag the right point up to 1000, and we can input 500 into the second point to give us a straight line. Dragging in a point node next, I'll change the method to by number along curve, and link it up to the inside arc. For the number of points, we need to look at the independent input for the lawcurve, and you can see here it is a series from 0 to 10. And this is important because it relates to the number of outputs we will get from the lawcurve. So in this case, there'll be 11 outputs from 0 to 10. So in the point node, we'll put in 11 for the number along. I'll just copy this node and move its input over to the outside arc. Dragging in a line node and changing its method to by start point direction and length. We can link up its start point to the point 1 node. The direction will be the base cs.z direction, and for the length, this is where the lawcurve values will be used to generate an increasing line length based on the lawcurve itself. So now we can just copy this line node and change its start point to point 2 for the outside arc. And now if we rotate the view, you can now see the increasing line lengths that is indicating the profile of our ramp. So to build up the ramp, I will drag in a B-spline curve and link the poles to line 1. This gives an error as it's expecting a point. So all we need to do is change the input to line1.endpoint. And now you can see the B-spline curve is generated following the endpoints of the lines. Again, we can copy this node and change its input to line2.endpoint, and we have the inside and outside profile of our ramp. From here I can drag in a B-spline surface node and change its method to loft curves, and link up the B-spline curves and a surface is generated between them. The last step is to drag in a solid node and change its method to offset from surface. Set the offset above to 0 and the offset below to 100, and link up the B-spline surface, and you can see we now have our solid concept ramp. Now we can automatically change the ramp gradient by dragging the lawcurve profile around. However, we can always go one step further. And so let's change the number of control points to 4. And you can see the profile is more of a B-spline curve, but we can change the order to 2, and now the curve turns into line segments. We can introduce a landing, say at 500, or halfway up the ramp, and you can see the ramp updates to reflect the change. The landing, however, is just at a third spacing along the ramp. So if we look at the lawcurve control points, we can see exactly what's happening and control the points and make some adjustments. So opening up the editor, it's easy to see that the control points are spaced at 0, 3.333, 6.666, and 10. We can easily adjust the location of the control points, which will reduce the landing length. For this example, let's change the 3.3 to 4.5 and the 6.6 to 5.5, and the landing length is reduced. We could easily change the values here to be more accurate values from the ramp. For example, if you had a ramp that was 8 meters long in plan, they could easily be the last value of our control points. And for the landing, you could indicate the start and end points of the landing as the middle 2 control points. So you could use something like this as the control points, where 0 is the start of the ramp, 4 and 5 is a landing midway height, and 8 being the end of the ramp at a height of 1000. The downside, however, of using the B-spline by poles for this example is the ramp profile is constructed as an average of the points, using its order. This can be easily changed, however, by using the B-spline method by points rather than by poles, and then it will pass through all of the control points and be more accurate to the planned profile. To refine the gradient, you can also add more control lines by increasing the number of points along the curve. Just remember to change the series range in the law curve to ensure that you match up the number of points from your law curve to the number of points you have along the line. This will give you a much closer approximation of landing transitions. This is just a concept ramp, and the low number in this example might just be enough. Using this approach isn't restricted to arcs that I've used in this example. Ramps can be created from any line string or B-spline curve. All you need to do is change the input nodes from arcs to either curve or B-spline, and then follow the same steps to achieve a variety of ramp profiles. Here you can see two others that I've created, one using B-spline curves and one using a composite curve. Hopefully you'll find a way to incorporate this concept into your next project. Until next time, thanks for watching.